Well, good morning. I'm Andrew Bate. I'm co-founder of SwarmFarm Robotics, and I'm also a grain and a cattle farmer from Queensland in Australia. Jossie and I started SwarmFarm back in 2010. Jossie's in the room here somewhere, hiding somewhere. There she is. So we started the company back in 2010, and we've grown to be a leader in the world of autonomy. While many companies have set out to kind of automate agriculture, and save labour, we started SwarmFarm for a completely different reason. We actually set out to create new farming systems to start to move our farming practices and become better farmers. We wanted to actually bring new farming practices into agriculture, and if you look at the last 50 years of farming and agriculture, it's all actually been around, here we go, thank you. It's actually it's all been about getting bigger, buying up your neighbours, buying more land, renting more land and getting more efficient. And then followed by that, it was about getting bigger machinery, larger machines and farming more land more efficiently with less labour. And on our own farm, at the peak of it, we had the biggest tractors John Deere made. We had the biggest sprayers you could buy with 1,600-gallon tanks, big 120-foot booms. And there was this kind of pivotal moment. We wanted to get bigger and be more efficient again, and we went out and custom designed our own planter and had it built. And now we don't actually hold the current Guinness World Record. They built a second machine after ours, serial number 2, and it still holds the current Guinness World Record today for the most acres planted with one planter in one day. And so, we're on the ego train of, we're going to be the biggest, we're going to have the biggest machines in our district, we're going to farm more acres, we're going to get more efficient. And we actually discovered we went backwards. We used to be a top 5% farmer. We'd been benchmarked against our neighbours and peers in the area, financially, agronomically, on our own farm. And as our gear got bigger and bigger and heavier and faster and more horsepower, we didn't plant seed as well as we used to. We used more chemical. Our spray booms are too unstable when we're spraying with such large machines. When we're planting with that massive planter, there was always some seeds were too shallow, some were too deep. The centre section was too heavy, the outer wings were too light so it could fold and we could transport it. And, we became crap farmers. And that was probably one of the pivotal reasons we started SwarmFarm. It was like, if we can go small, if we can go robotics, it's not about how many acres we can farm with one machine. It's not about the ego. It's about how do we be the best possible farmers, and what can robotics unlock for us in terms of new farming practices, new ways of growing crops we're not thinking of now. So I guess that's been an ethos that stuck with the company from the day we started. Sure, everyone's looking for a labour saving, but that's not our purpose. Our purpose is to bring better farming into agriculture. And look, we're really proud of our team as pioneers in this industry. To date, farmers with our robots have gone and they've gone and worked over 5.2 million acres across Australia. We've put around 220,000 commercial hours out with our robots, and there's been about 1 million gallons of herbicide saved. I don't think any other ag-robotic company's got numbers like that. And we're really proud of that, and we've done that in a country with no subsidies. We don't have a US Farm Bill, we don't have EU subsidies. All the farmers who have bought our robots have gone out and taken our loan with a bank, or they've paid in cash to buy that machine. And we stand on our own feet as farmers in Australia. It's something we're really proud of. We build autonomous robots for agriculture, but what I want to focus on today is what we call the autonomy trap and how not to fall in it. So what is the autonomy trap? Well, the last 10 years, I guess there's been plenty of hype, and probably every farmer in this room's copped some of that hype about what robotics is going to do for us, the impact it's going to have. And, we're starting to see some of it now, but it really hasn't had the impact that we've been promised for a lot of years. We've kind of got this world where innovators aren't innovating. When was the last time a Deere or a C&H released a true innovation for the horticulture industry? Sure, we've seen some incremental stuff, but we haven't seen true breakthroughs in terms of innovation. Farming systems haven't changed. We've had a few incremental improvements, but truly we're still farming the same way we were 10 years ago. Not a lot's really changed. We all struggle with the availability of labour. Our farming systems are truly defined by the labour we have available. And yet, there's been hundreds of millions, probably billions if you start adding it all up and look at the blood, sweat and tears and the VC money and all the money that's gone to ag-robotics for this industry. And it's certainly why all of us are here at FIRA today. We all believe in this industry, and we all believe about the impact robotics is going to have. So we've kind of seen three distinct categories form out there in the ag robotic market. The first one's what we call driverless tractors, or kind of sort of strap-on aftermarket kits. It's kind of a defensive play led by incumbents, and they're kind of positioning themselves in the market. They own huge chunks of the market out there for agricultural equipment, and they're fighting to keep that sector of the market. But it's kind of, incremental at best. You get a driver out of the cab, but we're not really creating much new value in the industry other than getting a driver out of the cab. And the aftermarket, kind of the strap-on kits, are sort of going to become an incremental feature on tractors. They'll either sort of be acquired or disappear as they become irrelevant, as some of these features become features in tractors anyway. The next category is what I find far more interesting, and obviously eco-robotics is a really good example of this. It's far more interesting, and what you're seeing here is a lot of this technology you'll see at FIRA, particularly out in the field demonstrations. And the key here is these are highly focused solutions delivering value and solving really deep problems that we haven't seen solved before. And so it's creating new value that first category doesn't get. And whoever works out how to robotically pick an apple just opened up a $45 billion market opportunity. So if you look at stuff like laser weeding, strawberry pickers, tethered robots that pick apples, this category is creating new value that driverless tractors don't get. So it's a really important category. And the challenge here, though, is that one-trick ponies don't deliver new farming systems. They deliver point solutions to really deep problems that need solving, but they don't deliver an entire farming system. The next category is what we call integrated autonomy, and these are autonomous robots that are built with a developer network that's specifically designed to integrate the smart tooling out of that second category together and bring it into a farming system. And it kind of, brings together value of multiple point solutions and starts to create real change in agronomy and real changes in farming systems. So with the first category is kind of, driverless tractors, it doesn't create much new value. The second category is far more interesting, delivering deep solutions to problems and really delivering value in the industry. The third category is integrated autonomy, where autonomy really sits, and it captures the value of that second category, integrates it into our farming systems, and delivers change in our industry. We live in this world where 80% of the US farm equipment's built by 3 manufacturers, and we've got the thinking of just 3 companies sort of defining the way we farm. We go to the dealers, we buy their equipment, we set up our farm to work with that equipment. The blinkers go on, and it's like this tunnel vision forms around how we farm with that equipment. Our agronomist makes recommendations based on crop rotations, how we set up an integrated pest management for the season. And we've kind of got this tunnel vision around that equipment about how we farm and our farming systems. And yet, we've got this perfect melting pot now of technology that's almost ready to go, or is ready to go now in ag robotics. I mean, we don't need hundreds, we don't need thousands, we need hundreds of thousands of developers around the world developing point solutions and solving deep problems in agriculture. We need new ways of thinking and new ways to do it, because we've got this melting pot now. You've got computer visions come to light. We've got AI now is going mainstream. You've got big data, we've got connectivity and advancements in robotics. And this is all coming together now, and now is the time we can truly capitalise on that. Things like NVIDIA GPUs really only became mainstream in the last few years. Elon's largely solved connectivity in the field now with Starlink. AI has really come to light really in the last 12 to 18 months with ChatGPT and our awareness of what we can do with artificial intelligence. So there's a real opportunity now. And it's not going to be one company. It's going to take multiple parties around the world to truly deliver this. And we're going to see a tailorization of technology, like, technology that's actually designed for your climate, for your soil type, for the crops you grow. Are you a biodynamic farmer? Are you conventional? Are you organic? Are you a GM crop grower? We're going to start seeing technology that's built for your farm, your soil, your climate, your production system, the way you market your crops. We haven't seen that with the big 3. We haven't seen that up to this lead into really deep solutions in agricultural robotics. So we really have this opportunity now to start delivering specific tools for our farming systems. So what's our part in all this? Well, at SwarmFarm, we've built an ecosystem called SwarmConnect, and it allows other companies to integrate their technology onboard our robots, and we carry it to market in autonomy. So what we do is we specialise in deep integration of advanced robotics onto board our autonomous robots. We've got one out there on the display there today. It has a sprayer on board. We don't build sprayers, we just build the base robot, and we've got 8 other companies that build sprayers that are specialty designed to go on board and integrated on our robots. And come down and have a look at it, we can tell you more about it. But we're not talking about 3-point linkages and PDO shafts, we're talking about deep integrations that go all the way down to the AI, all the way through the data flying off those attachments on those smart robotics that come through an autonomous machine and delivered into your field that actually starts to shift your farming system. And my engineering team hate this, but it's a 1 + 1 = 3 equation. And it's an equation that actually works, forget about the maths. There's now more weed detection technology delivered in the Australian market on board our robots than there is in the entire tractor and sprayer market in Australia now. Now, Australia is the fastest and the biggest adopter of spot spray technology globally. And it's been a phenomenal success for us, and farmers are choosing to deploy that technology now, integrated with autonomy on our platform. And it's a 1 + 1 = 3 equation. You can buy spot spray technology already, but when you integrate it with autonomy, you get a benefits better than the two things on their own. So a farmer using our robots with integrated autonomy with spot spray technology is getting a better result than a farmer who might be using spot spray technology on a conventional tractor or a sprayer right next door. They're changing their crop rotations, they're changing their pest management program, they're changing the spraying around the timing around their sprays, they're rotating products more often, they're bringing in different modes of action. And so we're seeing a real shift. Those farmers are getting out of bed and making a completely different decision when they get out of bed than a farmer next door who's not using integrated autonomy. And for me, and I talked about the ethos of our company about bringing new farming systems into play and how that's something we set out to achieve. To me, I see a great sense of pride out of that. We're already seeing that shift already with the farmers that are using our technology. So I guess to finish off, the future is yours to own. If we can do this together, if we can all win together, farmers, robotic ag tech developers and the horticulture industry at large. Support the companies you see here at FIRA because they're the true innovators that are delivering this change. We're not going to see it from the incumbents. We need the thinking of hundreds, if not thousands, of different developers around the world developing this technology. And it's so key and it's so awesome to be part of FIRA here today to see this technology and play our part in it. Thank you very much.
You have 8 minutes, about 7.5 minutes for Q&A with some flex time. You have about 7.5 minutes of Q&A.
Yep.
Yeah, could you explain a little bit about your robots and how they communicate and work collaboratively with each other if they do?
Yeah, absolutely. So we build, we're an all-in company, so we build everything in-house. So we develop all of our own autonomy stack, all of our software that makes it autonomous. We release our own apps on the App Store, we prototype, we build, we manufacture in-house. We sell our robots and we support them to end of life. Our robots are quite small, so in the broadacre world, our robots, they're around 2.5 tonnes, so they would be, for a farmer who's, say, a corn or a grain grower, probably around 1/4 of the weight of the machine they'd be using now, so very lightweight. And they work together in fleets or swarms, so instead of one large machine, you'll put 2, maybe 3 robots working together in a field. And it kind of scales in your operation. I mean, we've got robots running on 40,000 acre farms now. Then 90 horsepower, 40,000 acre farmers don't buy 90 horsepower tractors, now they do. Well, they buy 90 horsepower robots. And then we've got robots running in horticulture, so particularly in the orchard industry now, we're getting more and more interest and more traction now with horticultural robots. Running in both vineyards and also macadamia nut orchards. We've got some going into citrus shortly as well. And so it kind of scales to the size farm that you're running. I mean, obviously, in orchards, machines never did get big because they couldn't fit between the rows, so it equates to more robots, on a farm. In broadacre agriculture, row crops, cotton, it's kind of, it is a farming shift. Like, we talk to farmers and they'll say, I need to, spray my whole farm in 10 days. And with a robot, we have to explain it's a 1 + 1 = 3 equation here. We're not replacing your traditional sprayer. This is a different way of farming. You're going to run huge hours on these machines and you're going to change your spray timing, and spraying your whole farm in 10 days may not be the way you do it in the future because of the shift in the way it kind of rolls out. So the swarming of robots and the numbers is specific to the farming system and the size of the farm as well. But and I would say our robots, we have one model, and it's like a piece of Lego. You can kind of configure it how you want. So the robot you see out there today is set up for row crops. It's a medium height one on 120-inch row spacing. And the same robot, you can pull the axles out and put ultra narrow axles down on it. It's only about 18 inches off the ground for working in orchards and horticulture. It's really compact. Looks like a completely different robot. It's actually the same robot, just reconfigured. Then for the cotton guys, we have robots that are about 6 foot high, I think, underneath, so they can go over the top of things like cotton as well. And so the same robot, you just reconfigure the axle and you have a high clearance machine as well.
Can you talk a little bit about feedback mechanisms and what kind of information that the growers are using? So then how does this really fit to their workflow? And talk a little bit about how they're using this tool.
Yeah, absolutely. So as part of the deep integrations we do, when we do precision weed spraying, so computer vision based spot spraying, all of the data, all of the information coming off that attachment that's integrated on board our robots flows all the way through your iPhone. All you do to put our robots to work is use an iPhone. That's all you need. There's no laptops required. So every weed that's detected is marked on the map. We then timestamp it with the position, the wind speed, the temperature, the humidity, the product, who the operator was that set it to work. So we've got all the provenance of that information. So that's another integration that we do in terms of weather networks. We have not just weather stations on board, but then there's fixed weather stations in fields. Now we're connecting to inversion stations as well, particularly for high drift areas where it's a concern. And that deep integration then comes through to all of the fault codes, all the setup, all the configuration of that technology as well. So you can calibrate the machine, you can set the spray pressures, you can set all the different things that are needed on that sprayer. Even the integration of obstacle detection. So for something like a sprayer, we look at the geometry of how that sprayer is configured, and that feeds through to our obstacle detection system. So if a sprayer is folded in, it has a different viewpoint of where an obstacle is versus if a sprayer is out working or if the boom's lifted up or down and things like that. So it is defined. I mean, the data that flows and the information that comes off and how that's integrated is defined by the partner, the SwarmConnect partner we've integrated with. We do have a back end there then that keeps all of that data, saves it there. We call it Farm Manager. And all of the data, all of the operational data goes into that system, and it's all saved and kept for future reference as well. So it all comes together in the back end on a FIRA website as well.
Got about 2 minutes left.
So you mentioned that you're kind of changing the way that growers are interacting with their farming practices, that 1 + 1 = 3 mentality. How are you actually developing those new practices alongside them so that they know how to best utilize your equipment?
Look, we're not. And I think that's the power of more people thinking of being able to create an agriculture. A lot of it's driven by farmers that are taking our robots on, and they'll come to us and say, can you bring this other piece of technology on board now because I want to do different things? And a good example of that, one of the cotton growers we worked with is a cover crop grower. He used to grow half his farm to cover crop, half to cotton. Then he'd rotate it every odd year. So it was kind of 1 year of cotton, 1 year of cover crop, 50-50 of his farm. He's now changed his farm, and he plants cover crop between his cotton rows now. So every year, half his farm is cover cropped, but it's in strip cropping in between his cotton rows. And so that's been a big change for him. Like cover crops and cotton, specifically in the Australian landscape, is not common at all. Now he's pushing a new system with his cover cropping, and it's been driven by him. And that's the power of letting people innovate, I think, on board a platform.
We're going to give a little bit extra time for another couple questions, if there's a couple more.
I'll ask two if I can.
So as we go to more smaller machines, I guess what's been the experience with supplying them with more spray, and how have you guys addressed that challenge?
Yeah, so we have an autonomous dock and refill system. We released it at FIRA last year. Our robots can come in, refill themselves, it batches all the chemical in, and we haven't done it yet, but we can do granular products as well, so fertiliser and seed. And that allows us, I think for me it was a really big thing. We set out to make the smallest, lightest equipment we could in agriculture. We knew if we're going to have small machines, they could only hold small amounts of commodities. And so that dock and refill system has always been a key part of our product. It now means that, we can have, and I talk litres because we're Australian, but I think they're 400-gallon tanks, which is about 1,500-litre tanks. Means that a small machine with a small tank can keep up with the largest machinery with the largest tank size, and the robots just keep cycling through, refilling themselves, going back to work. And it means we can now get true 24-hour operation all through the night, all through the day, provided the conditions are good. It means we can get 100% uptime out of our robots. So it's a game changer for us now. We've got 2 customers out running it commercially, and I think a large portion of our customers will take that technology on and add it to their fleet now, because it just means they can stay light. It means their robots can be lower cost. They don't need large machines. It's opened up a lot more blanket spraying now, whether it be biologicals, liquid fertiliser or conventional products, that we can now have a small machine that only weighs a few tonne that can keep up with the biggest things that C&H or John Deere kind of build out there. So it's been a real unlock, and it's the final thing that tethered farm machinery size to productivity. I mean, if you wanted big productivity, you had to buy the big 400 horsepower machine with the big tank. Now you don't. You can have a little machine that weighs 2.5 tonnes that can keep up with something that weighs 20 tonnes. So it's been a really big thing for us.
Well, thank you.
Terrific. Thanks very much.